So perhaps you've run into a scenario such as this one. You can't understand why this piston won't retract. I mean, it's not powered, is it? I mean, this redstone block isn't even touching it. How does it make any sense? Welcome to the wonderful world of quasi-connectivity in Minecraft. Before we begin, I gotta establish the difference between quasi-connectivity and BUD. You may have heard the terms be used interchangeably, BUD powering, QC, but a BUD, or block update detector, detects when a block changes state. In this instance, we have a line of rails that are going to turn on and off, and rails don't actually provide power. You can't put them behind a repeater and the repeater will turn on when you turn on the rails. And yet, when we turn on the rails, we get an output. That is what a block update detector is. Block update detectors are so useful, in fact, that Mojang decided to add their own version of it. It's called an observer. All right. Now, while you can use QC or quasi-connectivity to make a BUD, they are not the same thing. So let's explain QC. So I'm going to do it in two separate concepts. The first is that blocks can be made to be put into invalid states. In this example, we have redstone dust pointing into a block that's powering the piston. Now I'm going to push this detector rail beside this redstone dust, which will redirect it. Intuitively, you would think that the piston would retract, but in fact it doesn't. The way we can fix this is by giving the piston an update. Basically, we can just put a block beside it. That's one way to give a block an update. We can also do this in reverse, by the way. We can also give a block an update by changing the state of a block around it. In this example, we have activator rails. I'm going to power those activator rails with these sets of repeaters. As you can see, it updates the piston. The update range for certain blocks is weird. Like, for example, here is redstone dust, 1 block away, and another set of rails that's also 1 block away. And if we set this to an invalid state, you'll see that the rails don't update the piston, but the redstone dust will. Which is strange, considering that we're changing the state of this redstone dust and it's the same distance as this redstone dust, but it's not giving an update. Kind of quirky, but hey, that's the weird part of this. Just to be clear, a lot of blocks can be put into invalid states. I mean, pretty much most any block that has 1 or more or 2 or more states can be put into an invalid state. Here we have rails, and then you may have seen in world generation floating grass above pools of water. All you have to do to get rid of the grass, is to just give it an update. All right, so that explains how we made our first block update detector here. Here we have a piston that's on its head is a redstone block. That redstone block is powering dust, which is powering the block underneath the piston. When we update the piston, it pushes the redstone block over. That redstone block powers a repeater that powers a piston. The piston is extended, and as a result, it can't be moved. So this piston tries to push it, and then it goes, oh, I can't do that. So then it just chills. And because it receives no update, it doesn't immediately extend again. So now we can give it an update, it'll extend, and then we have a reset piston on the back there. So that's pretty intuitive. I think this is fairly easy to understand for most people. Now let's get to the more less intuitive part. These 4 blocks, the dropper, dispenser, and the 2 piston types, have what I'm going to be calling an extended redstone hitbox. Let me explain. So here we have a lever on top of a solid block. We have a 1 block space in between our solid block that's going to be powered and our piston. Now I'm going to activate the lever. Nothing happens. Then I'm going to update the piston. Look, it's powered. Now I'm going to turn off the lever, update the piston, and the piston retracts. In this example over here, we're going to have a lever that's touching the redstone hitbox I mentioned earlier, but is actually not touching the piston itself. But because it's close enough to update the piston, unlike this one up here, it's actually going to extend the piston immediately. In this example, we have a lamp that isn't affected by QC, and you can see that nothing happens. There are many ways also to update the block that's being QC'd. You don't have to do it by putting the power source really close. You can just put something else to update it. Like in this instance, we have a rail. In this instance, we have a note block. In this instance, we're using a QC'd piston and its head to update another QC'd piston. And that works. And a similar example over here. So now we can explain this BUD we have over here. This redstone block is QC powering our piston. When the piston gets an update, it's going to push the redstone block over, and just like before, we're going to have a piston to retract it, or a piston to push that block back. And there you go. Hopefully that makes your redstone contraptions make a bit more sense. Thanks for watching.